You know, Jeff, I thought they'd be lighter than that by the turn of the century.
So did I, Wilma, but the experts say that most cars in the year 2000 will actually be similar in many ways to the subcompact cars of today.
Well, this expert has a tricky question on that subject, Jeff. True or false? Most cars will have computers by the year 2000. The answer is true. In fact, some cars already have microprocessors, tiny brains that control many functions of the car's operation.
As our expert on tiny brains, you should know about that, Otto, but there's so much to learn about tomorrow's cars, we thought we'd better go to some other experts, too. So, Kathy Chiampa and Marty Gould traveled by Newsplane 5 to cover the story with some of the automobile brains at Chrysler, General Motors, and Ford.
Jeff, with us here in Highland Park, Michigan at Chrysler's world headquarters is Don Geschwin. He's Vice President for Product Planning for the Chrysler Corporation. You know, according to automotive engineers, the real revolution in automotive science over the next 20 years will occur in the car's electronic system. Onboard computers will control and monitor almost every function of your automobile. Isn't that right, Don?
Yes, that's correct. In fact, many of our 1981 cars already have a microprocessor system that delivers a controlled ratio of fuel and air to the engine combustion chambers. And that system, in order to do its job, must measure the engine temperature, the air temperature, the spark control, the engine load, and speed. All of these factors help control the operation of the fuel system to make the car perform at its best.
And taking that even a step further, I understand that you are working on cars right now that have manual transmissions where the computer controls the shifting and the clutching automatically for you. How can that be? Why not just use a regular automatic transmission?
Well, a regular automatic transmission, Kathy, does consume power in its automatic operation. And the experimental work that's being done is to determine whether or not an automatically shifted manual transmission can improve fuel economy. And of course, the key to making that happen is the electronic control of the automatic shifting. It would allow the transmission to shift many times faster than the normal operator would be able to control it, and therefore keep the engine at its optimum performance levels.
In the year 2000, that they're actually going to have radar systems on board, too, which are going to help with the car's safety. How's that going to work? I mean, it seems like a radar screen and, you know, like being in the cockpit of an airplane, just about.
No, the intent is not that it be that difficult. There are a few research vehicles operating now that have radar systems, and essentially they are geared toward monitoring the car's position from an object, so that as you approach an object, the system would apply the brakes, perhaps through an anti-skid system which would pump the brakes, and avoid the collision in that manner. And of course, it also can be related to a speed control system, which allows you to set a speed, and it will continually monitor the position of the car relative to the cars around it. And by that technique could be a significant factor in avoiding major highway problems.
Radar systems, manual transmissions controlled by computers, and Marty, in 20 years I hear that computers will even control the car's doors and steering locks and even the ignition.
Wait a minute. Wait, you're telling me that I'm not going to need a key to get into my car? I mean, I lose them enough as it is, so I'm not going to need it anymore?
The future, Marty.
It seems fascinating how fast everything is going down.
So it's going mighty fast for us too, Marty. It's a very, very active and high-interest area. Yes, it's correct that we may have cars in the future that you don't need keys to operate. Through a series of coded push buttons, you may be able to open the doors, start the engine, operate the complete vehicle.
All by push-button control.
Correct. But you better know your own number.
Now that certainly computes.
You can say that again, 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 again.
I think it's time for some more questions about cars of the future. How many miles per gallon can you expect to get with the average car of 1985? A, 30 miles per gallon, B, 40 miles per gallon, or C, 50 miles per gallon? The answer's A, 30 miles per gallon. In fact, most new car manufacturers expect to exceed an average 30 miles per gallon for their 1985 models. But now I have a follow-up question for you. Try this one on for size. By 1995, the government may require automobiles to go farther than 30 miles on a gallon of gas. Our question is, how much farther? A, 10 miles farther, B, 20 miles farther, C, 40 miles farther, or D, 55 miles farther? The answer's D, 55 miles farther. According to published statements by the U.S. Department of Transportation, cars may be required to get 85 miles per gallon by the year 1995.
Now, that doesn't compute, but I guess anything is possible. Okay, by the way, how did your job interview go, Otto?
Not so hot, Wilma. Seems some guy named Ted Henry has more experience.
I hope you don't have designs on my job, Otto.
Oh, well, speaking of designs, Otto, how would you like to take a look way down the road?
Wait till I turn my crystal ball to Channel 5. Aha.
Okay, let's take a look. Are you there, Kathy Chiampa and Marty Gould?
We're here, Jeff, at the General Motors Tech Center in Warren, Michigan, a suburb of Detroit. This 330-acre complex is the Research and Development Center for GM, and with us is William Root, Executive Director for Advanced Product Engineering for the GM engineering staff. Bill, tell us something about the development of power plants for the future GM cars.
Well, Kathy, we have a number of important developments underway now. One of them is a coal-fired gas turbine for automotive use. Now, a recent technological development has been powdered coal, powdered to a size and to a chemistry that makes it feasible for an internal combustion engine like the gas turbine. And we think that with the availability of coal being such as it is in our country, that this is a very exciting and important development.
And Bill, what about electric cars? We've heard so much about them as a wave of the future. How are they progressing?
Well, as you know, Marty, we've announced the intentions to have an electric car in production by 1986. But the viability of the electric car today is the battery technology. We expect to get a battery life of 30,000 miles. It will be the kind of car that will operate acceptably in today's traffic. It will accelerate 0 to 30 miles an hour in about 8 seconds. It'll have a top speed of about 60 miles an hour. And the refueling of the battery, if you like, will take about 8 hours to completely charge a totally discharged battery.
And what about the internal combustion engine? Is there anything new on the drawing board for that?
There's a great deal new on the drawing board, Kathy. We're by no means through with the conventional gasoline and diesel engines. We have vehicles, experimental vehicles running today that get a combined urban and highway fuel economy of more than 50 miles per gallon, and we expect to do much better than that in the future. It's attention to the development of the engine as well as the powertrain and the vehicle itself. Better aerodynamics, lighter weight through the use of new materials.
Hey, that's great. You know, we're really beginning to see the shape of things to come.
You know, and speaking of shapes, Jeff, I have a question for our audience. True or false? Among current cars of all makes, there is a 15% difference in gas mileage that can be traced directly to aerodynamics. The answer here is true. Body shape is extremely important for overall fuel economy due to its effect on air drag.
Right, Wilma. And tomorrow's cars will shape up even better. Let's take a look.
Well, now we're at the Ford Motor Company Plant and Design Center in Dearborn, Michigan, and we're here with Don Kopka. He's the Vice President for Design, and we're going to talk about the shape of things to come, quite literally.
Don, what are the future cars going to look like? Are they still going to rust?
No, they won't rust. As a matter of fact, most of today's cars don't. We're using new materials such as zinc-coated metals and aluminum and a lot of plastics, and you'll see more use of that in the future. The future cars are going to be smaller, sleeker, more aerodynamic, more package efficient, and get better mileage.
Okay, Don, why don't you show us some of these future-type cars? We can get into this. We've seen a whole bunch of them over here Maybe you could start by telling us some of the things that you've been working on around here.
I'd be glad to. We have one right behind us here that we can uncover that's
okay.
never been
We'll do
seen
this.
before, as a matter of
Never been
fact.
seen.
No, it's never been
Well,
shown
we're
to the
getting
public.
a treat.
We'll pull that out.
And this one is quite representative of the car of the future, I would say. This is a family sedan that would seat 6 people comfortably. It does it in an overall size that's smaller than the cars we know today, and you can see from the shape of it that it's very aerodynamic. It was tested in the wind tunnel and has a very low coefficient of drag. And in addition to that, I like to think that it's very attractive and exciting, too.
We're seeing a major change then from more of the boxy type cars that
Very
we see on
definitely.
the highway today.
Yeah, the original concept of efficient packaging, I would say, was to put things in a box. But the problem is that the box doesn't move through the air very well. A car is a dynamic object that has to move through the air, and that's why we're doing all the research in the wind tunnels today to try and make it as slippery as we can.
Don, what is it about this car that makes it aerodynamic?
Well, I think we can demonstrate right on the car, Kathy, starting with the front end here. This air dam below the bumper keeps the air from going underneath and helps to keep that cleaner. And then the flush headlamp so that you don't have pockets in there. The sloping hood going into the very fast, clean windshield helps. And the flush wheel covers even to keep the air from going back into the wheel. And then you'll notice there aren't any outstanding moldings, the usual drip moldings. It's flush and clean all the way around. In the back, the fast backlight and the covered rear wheelhouse contribute to giving it a very sleek, slippery shape.
Maybe someday, if I'm lucky, make enough money, I might be able to own a car like that.
It's gorgeous. Thanks a lot,
This will
Don.
be your standard car in the future.
I feel like we've been a little bit into the future.